Hey, I wanted to make a quick video here about this new circuit bent project I did, and I wanted to go over what I did to this I think it's a 70 PSS-70 old Yamaha keyboard, and how I did it. So in case anyone else wants to do it, you totally can. So I've got this little GoPro here, and I'm just using the internal microphone, so hopefully this all works out. So first off, I'll just kind of go over what I did. Patch bay, clock freak out, fuzz section, delay section over on this side, and then I did a kind of pattern thing over here to kind of just do some wacky stuff. And then I added, of course, a 1/4 inch out. And as you can see here, I'm still using the DC power because I went around and traced everything with my multimeter to make sure I wasn't fucking with anything that was super high voltage. And I was able to find some nice pins that put out a nice higher voltage than what all the circuitry inside here runs off of, which is 5. And I actually used that to power the echo circuit, which was pretty handy because it wouldn't work on 5 volts. So let's go over a little bit first about what the heck is happening in this thing. So there's 2 chips here. There is a really big chip that's got 60 pins or whatever, and it's like an XM something 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 something. So this basically is, I think it's your brain. And then the coolest chip in this is like a YM something something something, but it's an FM synth chip. And these are connected by a bunch of data lines. Now when you push buttons on here, you're activating something in here, like a status in here, and it's sending the info through through these data lines, and is telling the FM synth what to do. So for example, if you were to choose a different patch from this to, I don't know, what is this? Oh, that one's not that different. There you go, that was a different one. There's something going on here that's telling this what to do. So what I did here for this patch bay, very common bend, is I snipped all of those. So I cut the traces, this common data bend that a lot of people do, and I basically just added those all to patchable connectors so you can interpatch them, you know, and put weird stuff where it's not supposed to be, and you get some wackiness out of that. So let's see here, I kind of lost this guy. So for example, if I just was to cut this, now it's sounding very different. But it's all, you know, it's a circuit bend, so it's all unpredictable. The one thing is, though, every time you boot this guy up, you have to reconnect all of these as it is, otherwise it won't boot. So yeah, a lot of different values you can find there. And I tried a bunch of different things with this with these data lines, which I'm sure it kind of acts like a shift register and is sending all sorts of wacky voltages like that. And I tried to listen to them, and they sound like pulses. And I tried to build a frequency oscillator that would send stuff similar to this into these pins, and I couldn't really get anything extraordinary besides just a small couple glitches. So I just decided to leave it as a simple patch bay, which is easy to use. So I also let's go to the next section here, is this clock bank, right? So basically there's a ceramic crystal oscillator in here, right? That is, you know, connected to the YM chip through 2 pins, the YM FM chip. And when you connect to these pins, it sets this frequency inside of this chip here, so it knows at what speed to run at, right? So what I did is I added a way to basically interface with these connections. So first thing I did is I cut those, right? And I added a little Schmidt trigger that creates a square wave, and I think you guys hopefully are all very familiar with it. But it's a 40106 CMOS hex Schmidt trigger. These are pretty cheap. Basically, you can create this little oscillator circuit with the gates using a capacitor and a resistance, which I have here at this frequency knob. And then I connect the output to one of the pins here. Then I also added a way to change the capacitance value of this square wave oscillator, so that can be variable thanks to this rotary switch. And then I added a way to re-engage and disengage the ceramic oscillator, or the crystal oscillator in there. So basically you get 2 options then. You get the ability to play with a way of sending a square wave into the crystal oscillator, essentially, and I guess it modulates itself or something. And then there's a way to just use the square wave and you disengage the clock. So a lot of wacky things can happen. So, for example, if I was to start on the smallest value capacitor, they go small, medium, large, and you find a frequency that starts to do something, then you can control the amount of that. So this is just like a resistor, variable resistor that controls the amount of the frequency going into the clock. Right? All sorts of wacky stuff can happen from that. And you can mess with this, get all sorts of weird noises out of it. So a lot of fun there. So who knows what's going on, right? A lot of randomness with that, which is a lot of fun. And then, of course, you could get even lower. So the frequency of this guy is rather high, so the higher values definitely do a little bit more when working with the clock. But if you were to disengage it, you can sometimes find pretty slick values here. And of course it does crash a lot, as with most circuit bends. But let's... So you're getting some cool sounds out of that when it does work. So now clock's disengaged, just using this low square wave thing, right? Changing the frequency. Get some cool weird drones. And because it was super drony, I was like, well, what can make this even cooler? Well, how about a fuzz circuit? So I've been etching these boards lately with ferric chloride and a laser printer doing the toner transfer method. And I was using an iron at first, and the iron was great, I guess, but I failed a lot. And bought a cheap $20 laminator on Amazon that basically just applies a bunch of heat and rolls it through. So it's just kind of, it speeds it up. You don't have to push down so much with the iron. And I've been having better results with that. So what I did is I just kind of made a little fuzzy circuit here. But it was an interesting circuit that not only had, you know, a gain for the fuzz, but it had some cool options to toy with the transistor biases. Or no, not transistors. These are like little op-amp biases. And then there was kind of a cutoff in there that I found, which was sweet. So I added this little mix pot to go in between them. So let me turn the amp back up so you can hear what it does. So now I'll pan on over to the fuzz, right? Amount of distortion here. The bias kind of plays with it a little bit. And then the cutoff. It's not a real like resonance low pass filter cutoff, but it kind of sounds like it. And given this is a weird project anyway, I figured it was good enough for right now. And of course you can blend in between that, create all sorts of weird textures. And then I noticed sometimes things get a little too bassy. And for a long time I was having this really bad buzz coming out of this. So I added a little high pass filter, which is really simple. It's basically, you know, your output jack here. Like here's your signal. And I'm just going through like a 1K or something to keep it from hitting 0. And then I got my pot here. And that is going to ground. So you basically just get to roll off a little bit of the lows when it gets too boomy. You may not be able to hear it in this little video, but it can help sometimes when things like really acting up. Right? Then I had made a little guitar pedal recently with a PT2399 chip based off of this little circuit designed by Mad Professor. It's called the Deep Blue Echo. So I plugged this synth into there, and I was like, man, that sounds really good. And I was like, why don't I just build another one and put it right in here? So I did that. So now, let's go back to regular. Reset this thing. And so there's a mix here with the delay. Delay times. Classic tape bending kind of modulation effects here with the delay time. And then an amount of how much it delays. And what's cool about this, it will go into like self-oscillation, which can be used for more cool stuff. And then the way that this blockchain is set up is, you know, it hits this first, hits the fuzz section first, then it goes into the delay section. So, for example, if we were to do something like, you can hear that change in cutoff lasts forever. And I thought that was fun. So, sometimes this thing's going so nuts that the keys stop really being reactive. Because, like, let's say you got this clock speed going so low that, you know, the keyboard just kind of stops working, and you start interfacing it with just the patch bay controls, which are also sometimes touch sensitive, you know, which is kind of fun too, whenever you can find that. But that's why I added this little section down here, which is basically just utilizing a divider and some other patches I found on the keyboard matrix. And the other gates of the Schmidt trigger. So my one oscillator here that interfaces with the clock is just one of these gates. There's like 5 more gates that I use. So I set one of these other ones up to interface with this divider chip here, the 4040 classic divider. And so I'm sending one of those outputs into the clock here, pin 10, grounding pin 11, and basically just have these switches here. These output steps are controlled by these toggle switches, and maybe you can see that here if I increase the clock speed. So there, now it's blinking, right? And so you can just see there's different things you get, and this is actually a 3-prong LED, so I'm sending 2 different signals into it, so that's why you got like 2 degrees of brightness. But what's cool about that is it basically just jams this keyboard. Yeah, like it hits like every key at once as you send a voltage from the output of this divider into just the keyboard matrix. And I'll show you that. And this LED over here is just another rate indicator. And you can see this guy just kind of doing what it wants. But you can change this, and it just kind of toys with where these things go, and it starts to sound different, which is kind of nice if you want a glitchy sound, but you don't want to be playing the keyboard. When it is sending sound into this keyboard, though, the keyboard's disengaged, so you can only play it use the keyboard when these things aren't freaking it out. So then, of course, throw that into the delay, get some cool, like, weird bubbly sounds. I don't know, just kind of fun here. What I did find, though, is these outputs of the divider were kind of hot for the keyboard matrix. So I used a little potentiometer between the connectors, and I basically went from the divider to one of these legs and the other leg to the keyboard matrix, and I found a value that I liked, and then I measured that value with the with my voltage meter thing here. I found it was very close to 15 kiloohms, so I put a 15K resistor on the output of all these steps, so it wasn't so jarring. It actually sounds kind of more fluttery and interesting, and I thought that kind of just helped the sound. So it's not so like bam bam bam, it's kind of just like a softer push, since I do think this is a little reactive when it comes to how hard you're pushing it, but maybe not. In fact, likely not. But whatever it is, that 15K resistor, I thought, just made it sound a little more fun. And then I think the last control I haven't discussed yet is this little mute thing. So I found a voice kill, essentially, which only kills the voice and not the drums. I think my sliders are messed up. They must not be working right. But anyways, so when you have like a drum pattern going on, you can turn off the voices, you know. And I tried a lot of fun things with this connection here, because I actually did have to cut a line between basically this FM chip here and an amp circuit. So I cut that line, and I was doing a lot of different things with that, such as like volume knob between the two lines. I used one of the other steps of the 40106 through a 4066 switch thing to kind of turn it on and off really fast. But since it's connected right to an amp, the sound of it turning on and off was really harsh. It was like constant, like popping, like pop, 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 pop. And I don't know, I didn't like it as much. So let's just see here. Let's just play with it for a bit. It's a lot of fun sounds. You just toy with this thing for hours, to be honest. A lot of cool stuff can happen here. Cool drones. Cool wacky glitch sounds. All sorts of weirdness. I've had a lot of fun playing with this thing. And I guess, hopefully, if you guys wanted to do the same, this video might help you guys do it. That's basically the whole process of how this works here. I don't think there's anything I didn't touch on. So yeah, that is this weird thing that I modified.